Lesson 26, reflection and mirror diagrams. We're going to split this one up into multiple parts because it's quite a long lesson. And it starts with your basic law of reflection, which is very straightforward. It says that the angle of incidence equals the angle of reflection. And so here we have, we have moving diagram. Here we have a diagram. We have a mirror. This is the mirror down here, surface. And here's a light ray coming in. There's your light ray coming in. That's your incident ray. It hits the surface and bounces back at the same angle. And the angle is the angle between the ray and the normal. What is the normal? It's just like the normal force. It's a perpendicular line to the surface. So whatever your surface is, you draw a line that's perpendicular. It's called the normal line. Just like the normal force, when you're standing on the ground, the normal force is perpendicular to the surface that you're standing on. All right, and so the law of reflection simply says that this angle and this angle are always equal. Okay, you can read on that, and then we go to plane mirror diagrams. A plane mirror is very simply a flat mirror. Pretty much every mirror that you have in your house is probably going to be a plane mirror. When you go to look in the mirror in your bathroom, it's a plane mirror, it's flat. And if you look in that mirror, there are some characteristics associated with the image that you see in the mirror. And those are as follows. The image will appear to be the same size as the original object. So if you go into the bathroom, you look in the mirror, you're the same size in the mirror that you are in real. The image will appear as far behind the mirror as the object is in front of the mirror. So to you, it looks like you're standing behind the mirror. And if you move further away from the mirror, it will look like you're standing even further behind the mirror. And then the law of reflection, which we'll just go over in a couple of seconds. So here's how it works for plane mirrors. And we don't do this very often. This is just an exercise in the law of reflection, really. So what we're going to do is we're going to have the light ray go from the image to your eye, and it's going to be basically like so, right? And this angle and this angle are going to be equal angles there. And what we do is we extrapolate because the image appears behind the mirror to this point here. And since I don't have yellow, we're just going to make this a green banana. That's a banana, in fact. And so this point corresponds to this point behind the mirror. And then we do it with the same with an infinite amount of points on the objects, which we're not going to do. We just, let's say this one here, so that we go something like this, again, this angle here and this angle here are equal, and then we extrapolate that one back, and we get this point and this points are equal. And then if you keep doing that, you'll get a green banana over here, which is supposed to be yellow, but I was too lazy to get the yellow color. So that's it. That's what a plane mirror diagram looks like, because it appears the image is behind the mirror. It's called a virtual image, which we will get to. You can go through your notes, and there it is right there. Okay, but then read this part here, because this is the part that is probably going to be new to you or a little freaky, and that is the concept of a virtual image. Because the image really isn't a thing behind the mirror, meaning that there is no true light rays back there, we refer to it as a virtual image. And with mirrors, if the image is behind the mirror, we call it virtual, and if the image is in front of the mirror, where you would expect the image to be, we call it a real image. Okay, so you need to know the difference between virtual images and real images. On to curved mirrors. I'm going to start with concave mirrors, and it will really be to your advantage to go onto YouTube and Google physics, concave mirrors or curved mirrors, and watch some videos related to it, because the visual will really help your understanding of this concept. So go pause this video, go do that, and then I think you'll find the rest of this video to be quite straightforward. So we have two types of curved mirrors, a concave and a convex. Just to demonstrate the difference, here is B, here's the mirror. This is a concave mirror because it looks like a cave. So that's a concave mirror. In other words, it's curved in this orientation. If I'm standing over here, and the mirror is curved this way, then that is a convex mirror. And you probably, the next time you go to a store or Max or 7-Eleven, you'll probably see convex mirrors. What do convex mirrors do? They allow you to see a wide, a much wider image than you would normally see from a regular plane mirror. So you can almost see around the corner in convex mirrors. And you also need to be very familiar with this here, the term converging and diverging. Converging means the image, the rays will, let's say the rays hit a boundary here, that they will converge, right? Those two converge. Diverging means that the rays will diverge away from each other, get further away. So converge means that they will get closer together and then meet at some point, and diverging means they spread apart. More on that. If you don't get that, we're going to be doing a lot of converging, diverging terminology. And the next part is concave converging mirrors. And the terminology that you need to know for that is right here. So here's a concave mirror, and you need to know what all these things are. C is the center. And remember, any part of a concave mirror is just a bigger part of a circle. That's a lousy circle. And C just means the center of the circle. So if I could extend this mirror right here, this is not a really part of it, not very curved in the right way, then the C is just the center of the mirror. F is the focal point, and it is always halfway in between the center and the actual mirror. V is the vertex. That's where the mirror meets this line here, which is called the principal axis, the PA principal axis. So make sure you understand all those. And now we can start doing ray diagrams. And ray diagrams basically are the rules for finding if you have an image in a concave mirror, if you have an object in front of a concave mirror, what will the image look like? All right, and all the rules are written for you here. I'm just going to kind of do my own example here. So just so you can see it as I draw it. So here's a principal axis. Here is a concave mirror. Here, let's say the center is right there. And let's say center is right there. And let's put the focal point halfway in between right there. Okay, and we'll start. The first one we're going to do, we're going to put in an object between the center and the focal point. So there's my object. And there are three rules. So my goal here is to find out what will the image look like. If I have an object in between the center and the focal point of a concave mirror, what will my image look like? And there are three rules. Rule number one says if a light ray goes parallel to the axis, then it will reflect, let's do it here, parallel to the axis, parallel to this axis down here, it will reflect through the focal point. So it will reflect through the focus. And that's just based on the law of reflection, because obviously you're hitting the mirror at an angle, you're not hitting it dead on. So here's the normal, there's the normal at this point of the mirror. This point in the mirror, there's the normal, and there's your angle of reflection. Angle of incidence equals angle of reflection right there. So it reflects through the normal. So that's rule number one. Rule number two is the opposite. Rule number two says if you have a light ray that goes through the focus, it will reflect parallel to the axis. So let's do that one in blue. So if I have a ray that goes through the focus, it will reflect parallel to the axis. Didn't quite get that one, that's okay. Parallel to the axis. And once you've done two of the rules, you actually have the solution. Now let's do the third rule. And the third rule says that if a ray goes through the center, it just reflects on itself, right? Which is going to make sense when I draw it. So let's say, see it in black. So first, let's extend this a little bit. So if it goes through the center, oh, this is going to be kind of tragic. The center, it reflects on, oh my gosh, that is really tragically bad, but I can live with it. Here, so if it's hitting the mirror here at a 90-degree angle, so it just kind of reflects on itself. And I've had to kind of curve it, even though it should be a straight line, because this is kind of an epic fail. This is why I should use a ruler and measure things out properly. And you should do that. And where those lines meet, that's where your image is. Okay, so excuse my terrible lines there. They should all be straight lines. That's where the image is, and that image has certain characteristics. As you can see, the original looked like this, and the image is going down. So because it's upside down, we call it inverted. It appears to be slightly bigger than the original, so we just say it's larger. And because it's on the same side of the mirror, as opposed to the plane mirror example where the image was on the other side of the mirror, we call it real. So those are the three characteristics that you have to know. And once again, a reminder that when you do these ray diagrams, you only need to use 2 of the 3 rules. Personally, I always try to use this rule here. No blue. Not blue, there it is. I try to use these 2 rules first, and then use the center rule as a third option. So you just need 2 of the rules to get a point of intersection of those lines, and wherever the lines intersect, that's where your image is. Okay, we're going to do more examples in the next lesson, so go right to the lesson 26-2.